I think a lot about what makes companies and products successful. If y'all know anything about me, you've probably seen me betting on all sorts of new things, old things, and things in between. Something I think about a lot is when and how does a technology get adopted into a developer stack? But also, very importantly, when does a technology leave a developer stack? Can we use these ideas to reflect on different technologies and when they do and don't make sense? And more importantly, how successful they will find themselves when they enter the market. This video is mostly focused on the business side of things, some amount, but I think it's a really useful mindset when you look at different technologies and things that you can adopt at your job or on your side projects. So, when I say the graduation curve, what am I referring to? The specific framing I have for this concept is that over time, when you start a project, you don't necessarily know how successful it's going to be and how much traffic it's going to get, how it's going to work in production, even if you're at a big company doing a big thing. We're going to pretend that that complexity grows linearly. So we have here complexity and time. Given that a project's complexity goes up linearly over time, I'm not going to put timeframes or anything here, but at a certain point, your traffic is massive, your databases are collapsing, everything's going to hell. Your needs when you hit a certain threshold of complexity tend to be very different from your needs before that. So like up here might be custom, like distributed service hell, but like all the way on the bottom would be Google Sheets is a fine DB. People often think that like these are good for early or late projects, but different projects have very different complexity curves over time. Like some projects might go for a long time. They might have a spike in complexity, maintain here. They might have a curve that starts way lower. They might even have a thing that stays really not complex for a while. Then they add one feature that instantly blows them up and increases the complexity a ton. There's a lot of different paths that your complexity can take for your projects, for your companies, and for the things that you build. But it's important to understand what services and what solutions make sense at what levels of complexity. One way we could think about this is I could put like 15 of these lines where it's like different sizes of EC2 container. We could say like this is a $500 month RDS box, and then this is like a $10 a month RDS box. Like, this is one way we could view this, but there's a lot of granularity going up and down, and you're gonna have to worry about scaling and switching to your database tiers correctly based on your traffic. And if you have one day where your traffic spikes a bunch, so this is a much more realistic traffic pattern for a lot of services. And as you see here, the tier of box on AWS that makes sense for you is very different at different points with a lot of shifting back and forth. And if you were to provision your RDS box based on the amount of traffic you had in this one point, and then you immediately drop back to like below what the $10 a month box can do, you're eating a lot of cost either by paying for that service, or you're eating a lot of time dealing with moving things around constantly and the stress of making the wrong choice at a certain time. Scaling these things is obnoxious, and worrying about this stuff sucks. Ideally, the services would handle that for you without being too complex to adopt initially. And that's the other thing to consider here is when you come from the top down, you can scale better and you have less reason to leave, but it's also usually harder to adopt. And the really interesting thing about a company like PlanetScale is they focused on this top level first. So if your company's the like mostly linear, I guess slightly exponential curve up, PlanetScale was built on top of Vitess in order to make the scale of services like YouTube, GitHub, and Slack accessible to the greater public. Most people couldn't set up a database to scale as well as theirs could, especially in the serverless era where things like connections started to matter much more than they used to. That transition normally sucks to do yourself, and I've had to migrate many a database as my complexity goes up. I'm going to compare two different services that come at this from very different angles. The first is one we talk about a lot on the channel. They do sponsor us, but that has nothing to do with why I'm talking about it here. I just think it's an interesting concept. Call this the PlanetScale zone. The PlanetScale zone is, in my experience, and from what I've seen from many others, is you don't really outgrow PlanetScale. Like your complexity can't really get to a point, or at the very least, your database's throughput doesn't really get to a point where PlanetScale can't scale to it. There is theoretically a point way up here where fine, just use Dynamo. It's like Dynamo is incredible, but the problem is Dynamo is much harder to adopt. It requires you to know exactly what the structure of your data is before you even start working on that database. PlanetScale is a much more traditional relational DB where you can do all sorts of chaotic bullshit, which I would argue is necessary as you grow and find success. And then there's companies that are on the other side of this. And here's where I'm going to put our friends over at Replit. This isn't because Replit is bad, it's because Replit can't scale. The goal of Replit is to help new developers write their first lines of code and find some level of success. But as soon as you're starting to succeed, it's going to fall over. Hell, we have a bot that keeps track of when I change my titles and thumbnails for my YouTube channel, and that bot's entirely fallen over on like a $10 a month Replit tier because it just can't keep up with a 15-minute cron, which is kind of insane. The goal of their service isn't to make you a service that scales infinitely. It's to help you write code, often for the first time, and have that reward of succeeding building code. Their theory is over time, they can make their service more complex and add the things necessary so that you don't leave Replit. But the reason I'm making this video and the argument I want to make is that going up from low complexity as a service is much harder than going down from high complexity, especially if you put in the effort to understand the people who are in this lower area. And that's what I think PlanetScale is doing exceptionally well, is they started at the top. They built something that you would never have to leave. And if you see here, you leave Replit pretty early. And if we take these same boxes and apply them to what we had over here, you'll see that like we don't get into the PlanetScale zone for a bit, but when we do, we're fine, but we dip in and out of the Replit one. And you get out of it pretty early, and theoretically you can go back in, but you're limiting the quality of what you do based on the success of their goals. And obviously over time, Replit's potential complexity is going to go up, but you're basically betting that your complexity rises slower than theirs does so that it can stay within their bounds. And also that they find success at all. With PlanetScale, you're not really betting in that same sense. The worst case is you have to leave and set up your own Vitess somewhere else, and I'm sure there'll be other services. You can always MySQL dump out of PlanetScale and go use that MySQL somewhere else. But the thing that makes PlanetScale special is that you don't have to leave. They will scale pretty disgustingly far, which is why over the last few years, the goal of PlanetScale isn't necessarily to build a more scalable service. They obviously continue working on that. They're doing incredible stuff with Vitess. They are the owners of Vitess, the open source project now. But man, their focus has been doing this. And I think they have found insane success with this. The reason PlanetScale made this incredible free MySQL for Developers course, which like it's actually insane how good this is for a free thing. They had Aaron Francis, who's a professional educator who's done software courses for a while now, normally paid courses. They hired him to work on this for a year so they could give it out for free. Because if they make MySQL more accessible, they are lowering this bar more and more, which is incredible for them and their goals, because the closer they can get to the ground, the more soon someone will adopt them and they never have to leave. And that's why PlanetScale is making the bets they're making. And that's why PlanetScale is making the cool free stuff they're making too, is they don't want you to have a reason to leave. To be realistic, complexity goes much deeper than this like one-dimensional thing I'm showing. Vercel, for example, will scale basically infinitely because it's just running on Lambda and edge functions. So if you architect whatever it connects to right, and your SQL database that is backing your Vercel is set up correctly, that will scale. But a lot of the enterprise features and the things a bigger team would expect are still in progress. They're making a ton of progress, and the stuff I've seen on the enterprise side is increasingly impressive, especially Vercel Spaces. But Vercel is almost doing the opposite right now, where if this complexity was number of requests, they're good, you're golden. But if this complexity was functionality for an enterprise, it starts a little more like, and it says PlanetScale, I know, just Vercel zone. This is the Vercel zone. This is complexity of like team needs for enterprise bullshit. It's like the weird like SAML stuff, the like VPCs, VPNs, the things that enterprise wants for good reason, for the security compliance, all that stuff. They're working hard to move this up so that they can catch you in all of that stuff as well. But that's what makes Vercel special, is I think they did a great job of starting a relatively wide zone, especially if your complexity isn't team need stuff, it's traffic. Then Vercel can scale to insane amounts of traffic and do entirely zero amounts of traffic, and the pricing is super reasonable. And they're scaling up with us. I would love to outpace Vercel's growth, but realistically their growth is nuts, and I think they're doing a fantastic job of keeping their curves here reasonable and not causing users to leave the platform or limit the success of their own services based on it. I think that's another important detail of the Replit zone, is realistically you're not just going to move out of it, you're going to hurt your service's success some amount, because you're going to plateau where Replit ends until you decide, okay, too much, we're out, and you break out of it. But when you're in something like this, you end up limiting the success you can find. And the most successful people tend to be the ones who graduate from this stuff quickly. And the harsh reality about Replit right now is that if you are a Replit user, Replit succeeded at what they're built to do if you leave Replit in the next 3 months. The Replit's done such a good job of educating users that it set them up to graduate from their platform really quickly and really aggressively. So if Replit succeeds at what they're doing right now, you end up leaving Replit. If Vercel succeeds at what they're doing right now, you end up wishing you could use it at your workplace, but you can't because they're missing some specific feature your company needs, but you're bugging your boss about it every day. And as soon as that blog post comes out that they added the VPN or firewall that your company needs, you can go back to your boss and say, hey, the thing's added, can we do it now? And then from the top down, Vercel gets introduced to your company's stack. And that's what I'm starting to see more and more of, is the companies realizing we need to solve the graduation problem. We need to make sure that when your service hits a certain level of traffic and that your team's needs hit a certain level of complexity, that our service is ready for that. And if you start with that level of complexity handled and you move down, you find success a little bit quicker, but you have to also invest in making things a lot more complex. This is why we didn't do this with Upload Thing. Upload Thing's going to look a lot like this, because if you break out of the 2 gigs of storage that we offer right now, you're fucked. Like you just can't upload anymore. We don't have a paid tier at all. Once we have a paid tier, this will bump some amount, but we're also missing a lot of features enterprises expect, like private files and signing directly or hosting them in your own bucket or off-prem support. All these types of things we don't support that keep us from being higher up. It means we're going to have a tough time continuing to grow, especially as our biggest customers start to outgrow us. That's an important balance we're going to have to work hard to strike. But if we succeed, developers will love us so much that even if they're forced to leave, the moment that we are ready for them again, I think they'll come back. And that's the goal of how we're building an Upload Thing. But it doesn't mean I don't look at PlanetScale with a little bit of envy that the best thing they can do right now is make a course, because they already handled the other half of that curve. I think that's all I have to say on this one. Another important thing to consider with this stuff is cost and pricing. PlanetScale's costs are hilariously cheap. Yeah, $600 a month for a team, but if you look at the actual cost of traffic, where $30 a month, 100 billion row reads a month, plus $1 per additional billion. That is nuts. Storage, people seem to think is expensive. Do you know how little data you store in a database? The reason storage costs money is because if you're encoding PNGs inside of your MySQL database, you don't understand PNGs or MySQL. Like the biggest database we have at Ping, which is like the core database for all of Ping, is like 80 megs. It's nothing. It might even be less than that, actually. In the free tiers, 5 gigs. There is not a database at Ping that doesn't fit in the free tier, to be very clear. Like, very clear. It is hilarious how cheap. 1 billion row reads a month for free and 10 million writes. That's insane. That's a lot of traffic. So they've done a great job of balancing these things out. They make it easy to adopt by making it free, making these courses, making these resources, making NPM libraries you can install to give you more reason to try them out. And then you fall in love, and then you go to your company and say, hey, can we use this here too? $600 a month is a lot cheaper than hiring a DB expert. And that's the other harsh reality is if I didn't have the option to do this, either Mark or I would have to become database experts or we'd have to hire one. And this is so much cheaper than the time that we waste otherwise. It's so worth it. It's so worth it. Anyways, this rant was a little different than usual. I normally don't talk this in depth about the business side of these decision processes, but I have thought about the graduation curve a lot and I wanted to detail it and put it in a video so I can reference this in the future. If there's any confusion or things I talked about here you want to hear more about, tell me in the comments. I'd love to know more. If you want to hear a more in-depth rant about how pricing for these services work and how I think they're often misunderstood, specifically how Vercel and PlanetScale are usually cheaper than something like AWS, got a video pinned there for that. Thank you guys as always. Peace, nerds.